Hello everyone. So this is my project on servo motor control. I've used, as you can see, the ESP32 for the control purpose and for wireless control of course, and my control element would be a micro servo motor. So the control mechanism is pretty simple. I press the switch and it turns on, and you can see the servo motor is rotating. It is basically in sweep function, so sweep function is like 0 to 180 and 180 to 0. So in such case, when I turn off the switch in any position, it will first go back to home position and then turn off the circuit, as you can see. And now the overall functioning of the servo motor and the overall control, as you can see, is basically through Arduino, and I've used Blynk as a tool, as a medium basically. So the Blynk would be my interfacing for IoT, and this would be my like you can see the Blynk control code and all. You must be notified with that. So coming to servo sweep function, I will just give the overview of how this thing works. So the objective of our project should be to make a system that is capable of driving a component, and the component here being the servo motor itself. So the overall objective is here in the loop. So in the setup part, it basically this code right here, it is basically to allocate the servo motor with all the PWM and the pin allocation, and checking whether the network is connected or not, the Wi-Fi would be connected, and stuffs like that. A sample of if I can see, yeah, here. So a sample demonstration of what it can look like, it would be here. Just a second. Yeah, so the servo motor function takes quite a while to upload because, well, of the memory issues. It's in the speed, you can see the speed is in around 80 megahertz, and it's Node MCU 32S, and the bitrate is some 115,200 on COM4 port. And here you can see it's uploading with the enable function, and let it upload to 100%, and then we will open the console window. The control is simple. Basically what happens is the servo motor is initially in 0 position. If it is not, then it will be pulled down to the home position, and when it is pulled down to the home position, then it will be swept whenever the system is turned on. Now in first case, let me show you. The serial monitor is here, and I'll reset the Node MCU thing, and as you can see the ESP32 is reset and it is connecting to my Wi-Fi, and it's the Blynk is showing. So now it's the ready ping 399 millisecond. So it's basically the ping time, and you can see that it's showing the status. So the status is around here, and let me go to the Blynk app, and here is the Blynk development tool, and let me turn on the switch, and you can see, you can hear the sound already, so you can know that the servo motor is moving, nevertheless I'm showing the camera or not. So now I turn off the system. Let's do some experiment with this. So right now it is in home position, and I have turned on the circuit and it's moving. Now I have turned on the switch, however what's happened is that it's 180-degree point, and now it's turning off at the home position. So the function is such that the servo completes its sweep function and then returns to its home position rather than returning at a specific position. That really affects the gears of the servo motor if it is not in the home position. So it is the best to pull the servo motor to its home position. That is all for today. See ya.